Understanding Proportions from page 278. Once we start getting into proportions, it has something for everybody. Proportions cater to those who like one method and like to stick with it. Proportions also cater to those who are a little more adventurous and like to explore and try to find their best option. Shortcut, if you will. Some of you like shortcuts. Some of you have enough number sense to use shortcuts. Proportions allow us to do that. Okay. Now, a proportion is an equation stating that two ratios are equal. If I were to give you 1 to 2, it looks like half is a fraction, but we'll write that ratio in fraction form. We'll call it 1 to 2. How would we make another equal ratio that would form a proportion with 1/2? Really? Which one? 2 to 4 would be an equal ratio. Therefore, they would form a proportion. Because all Willie did was said, you know what? I'm going to take the top number, my top term, my bottom term. I'm multiplying both by the same thing. I'm multiplying both by 2. And what I'll have there is a proportion. Okay? We can get that by multiplication, or we can get it by using what other operation if it's applicable? Division. You can always use multiplication to form a proportion, but you can't always use division. Could I have used division with 1 to 2? No, because it's already simplified as much as it can possibly be. Okay, but it is an option in some cases. What we'll have today is they'll give us something like this. Let's see. They'll give us these two. 2 to 5 and 8 to 20. And they'll ask, do these ratios form a proportion? Any ideas, any thoughts? Sarah? Good. What Sarah just did was she looked for a relationship. Okay? This is one of the options that you're going to have. And what I mean by that is she looked at the top number to the other top number to see, is there a way that I could get 8 from this 2? Is there a way I can get 20 from this 5? And you would say what? Times 4. If the top terms, or top term and the bottom term, are both multiplied by the same thing, or divided by the same thing, you'd have a relationship. A relationship. Very good. Okay? This is one of the options that you can use. Let's take again 2/5, 8/20. Another one. Simplify. Are one of these, or possibly both of them, able to be simplified? How about the 2 to 5? If we look at it like we'd look at a fraction, we've already simplified ratios. You did that on 6-1. Can you simplify 2 to 5 any more than it already is? No. How about 8 to 20? Can we simplify that? Do they have anything I can divide both 8 and 20 by, Austin? 4. What is 8 divided by 4, Austin? What is 20 divided by 4? 5. Now you have 2 to 5, 2 to 5. They're the same. They're the same. Simplifying is an option. And let's take this 2/5 and 8/20 again. And we'll use what's called cross products. Cross in the sense that it's more like diagonal products. What's a product? That's something you buy. Mathematically speaking, what's a product? Josiah. Answer to a multiplication problem. So, if I would go diagonally and multiply 2 times 20, Josiah, what would I get? 40. If I were to go diagonally and multiply 8 times 5, I would also get 40. If those are equal, you also have a proportion between those two ratios. Okay? It will always work that way. Yes, ma'am. Well, not necessarily, not with these quite yet. Sometimes it depends which way you go. Depends on how you want to look at it. If you take these two, Kishana, and you say, you know what, I'm not going to look this way, I'm going to look this way. How about I go from 8 to 2? Using division, I divide 8 by 4 to get 2. 20 divided by 4 is 5. Yeah, because look, you're not always going to see them like, you can have these same two ratios, but maybe it's written that way. Same thing. Look for that relationship. To get from 8 to 2, yeah, well, now I'm going to be dividing by 4. If I'm dividing by 4 on the bottom, I've got that proportion. It's all a matter of just perspective. There's so much with these proportions, so many different ways you can go, that it's, you know, I personally, I think it's great because you've got all these options in front of you. You can use whatever one you think it works best. Josiah. Oh, so let's take a look. Funny you should ask. Because you're right, they're not always going to work out. I just took that one. Okay. And right here, I would say in order, like I gave you before, I think the first thing you always want to look for is a relationship. It's the first thing you want to look for. Because if you can either find one, great, that might tell you a lot. If you can't find a relationship, it doesn't necessarily mean that they're not proportional. Is there a relationship between 12 and 4? What is it? What about 3? Divide by 3. 12 divided by 3 is 4. Now, in order for these to be proportional, this would also have to be true. 52 divided by 3 is at 14. Is 52 divisible by 3? Remember our divisibility rules? 5 plus 2 is 7. Is 7 divisible by 3? No. So this isn't divisible by 3 at all. Therefore, it would not be proportional. Look at your other option. What if you were to simplify? These can both be simplified. 4/14 would go to 2/7. 12 over 52, they're both divisible by 4. 3 over 13. Are those the same? They're both in simplest form. They're not the same. You've simplified them as much as you can go. Again, not proportional. Okay? So just because it works for one, that's going to happen. But it has to work for both in order for it to be proportional. Okay? I'll give you one to try. Simple yes or no. What do you think? How many think yes? And you think no. Okay? Josiah, why did you think yes? But is it by the same? Well, let's go this way. 5 times what is 20? 8 times 4 is what? What's 8 times 4? Is that the same? Therefore, not. That's all you need to know. Like I said, it's okay for this one to work, but in order for it to make a proportion, they both have to work by the same thing. If they don't, it's over. All right? Let's take a look at page 280, numbers 1 through 8. 280, 1 through 8. Some exercises, some practice. Look at number 1. 1 to 2, is it proportional to 50 over 100? Yes, it is. Absolutely. Yes, it is. How about number 2? 10 to 20 and 30 to 40. No, not quite. Looks nice, but not quite. 4 over 12, 6 over 8. No. 4, 42 over 6, 504 over 72. Why don't you give it a shot? Find out for sure. You can't guess. Can't guess. Either it is or it isn't, but you got to find out for sure. Give me proof. I need proof. Yes, you have to, like, write it out. It's a shortcut. You may not be able to see right away a relationship. What was our second step that we used? No, that was step 1. What was the second one? Simplify. Can I simplify 42 over 6, Sarah? To what? 7 over 1. Okay. Now, I can take this right here. I have enough information right here to test a relationship if I want. If I say 1 to 72 is times 72, I could, right here, test it and say, you know what? If this is going to work, 7 times 72 has to get me what? 504. 14, 49 plus 1. Did I get my 504? Yes, I did. Therefore, they form a proportion. That's just one way. Let's take that 7 over 1. Okay? Can I simplify 504 and 72? They're both divisible by what? Remember your divisibility rules? 5 plus 0 plus 4 equals 9. Therefore, it's divisible by 3 or 9. Let's see what it is. 504 divided by 9. 5 and 6. So now we've got 56 over 8. 1 times 8, 7 times 8, does it give us 56? Again, it works. Can I simplify even more? 56 and 8 both have 8 in common. How many 56s are, how many 8s are in 56? 7. How many in 8? 1. 7 over 1 equals 7 over 1? Yes, it does. So many different ways you can test it. If it's going to work, it's going to work. If it's not, you should find out right away. But they don't have a certain look. So when you see this, you have to still test it, even though, yeah, it was a little bit more work, but take the good with the bad. Understand that some of these, like numbers 1, 2, 3, they were all easy enough you could look at right away. Sometimes you actually have to do a little work. That's not a bad thing. How about number 5? 9 over 11, 63 over 77. Why? What's the relationship? Times 7. Good. How about 6? 72 to 8 would be dividing by 9. 23 divided by 9 is a 3. Yes. 7. 16 to 4 is dividing by 4. 27 divided by 4 is it 9? No. 3 over 2, 22 over 16. No relationship on the top to see right away. On the bottom, 2 times 8 is 3 times 8, 22. No. Okay. So you've got those options. Now, there are a couple other ones that we need to explore before we close the book on this, where we've got to find the missing number. But we go about it the same way. We go about it the same way. First thing we looked for with the other problems was a relationship. So let's look. Is there a relationship here between 7 and 21? Sure is. Times what? So in order to get this number over here, I got to multiply 35 times 3. Brandon, thank you. 105. Okay, try another one here. 12 over 4 equal to something over 28. Now, of course, you can only test the relationship between where you have both terms. And here is where I have both terms. Doesn't matter if it's top or bottom. They got to be the same anyway. So to get from 4 to 28, I've got to multiply cal by what? So then 12 times 7 becomes what? 84. Yeah. You're just finding the missing value. So when I circle, like, this is what we need. Okay? That's our missing number. Try number 11. 57 over something equals 19 over 38. What method did we use? How many of you used step 1? What did you find with step 1? Good. Very good. So if you go toward your missing value, that'll always help. 19 times 3 is 57. 38 times 3 is what? 114. Anyone use any other step? Yeah. Oh, you went the other way. Okay. Okay. It just gets, you're right, it just gets trickier that way. Because then you're going to say, well, what divided by 3 equals 38, which essentially you're going to multiply anyway. Okay? Anyone use step 2? So step 2, Joel, was what? Awesome. What did you simplify 19 over 38 to? Half. That's half. 19 over 38 is half. So 1 times 57, 2 times 57 still gives you 114. Okay? I mean, I think these are, I'm getting all math nerd excited up here. It's kind of fun to see, like, how different processes can still give you the same answer. And we still didn't even hit the third option yet. Because remember before, we had the third option as cross products. Okay? But if I look here, and I use these cross products, this is the method that will always, always, always work. Let's go ahead just to make it easier, and let's simplify. If I use those cross products, remember before I multiplied diagonally? 57 times 2 is 114, divided by 1 equals the 114. Okay? Now, even if I were to take 57 and multiply it to 38, I'd have to then divide by 19. If I did it right, I'd get the 114. But that might be more work than what we just did. Okay? Any questions? I'm going to do a couple more. Maddie, question? Kishana? Yeah. Didn't I give you like a second copy already? I just gave you the one? All right. 6-3. Take it out. You never got one either? You won't. 6-3. Numbers 1 through 8. Do the ratios in each pair form a proportion? So numbers 1 through 8, we're looking for yes or no. Okay? That's all. Yes or no. Now, 9 through 16, find the value that completes each proportion. So if I look at don't stop working on numbers 1 through 8, please. Stop working on 1 through 8 so you don't miss 9 through 16. If we look together at number 9 and we say 4/5 is equal to something over 15, I look for my relationship, I see it right away. 5 times 3, 4 times 3 equals 12. What number goes on the line? 12. That was the missing value. Put the 12 on the line. You've got that. You've written that down. Josiah, you've got that written down. Good. That was number 9. So where the question mark is this. Here's the line underneath. Write down the 12. Write that missing value underneath. That's what you found. 1 through 16, you've got about 11 minutes.